This is Lagrange Labs, and thanks for joining, everyone. Yeah, we're just gonna take a few minutes and welcome others who would like to join and get started soon. Hi, everyone. For those who are just joining, we're just going to give a few minutes for others to join, so hang tight. Welcome, everyone. Yeah, we're just waiting for more people to join. We'll probably start at the 5-minute mark, but feel free to, if you have questions that you want us to talk about during this X Spaces, feel free to go to our Discord. There's a place for you to submit questions there, or if you want, you could also quote tweet the announcement tweet, and we'll take a look and address any questions there. Okay. Yeah, it looks like we have some people joining still. I see some community members. Thanks for joining. We're excited to share more. Okay, Ismail, just double checking that you are in here and are able to speak. Ismail, is it?
Hello, everyone.
Oh, yep, there you
are. Great to see you. Great to see everyone here. I love such a turnout for the first space.
Yes, this is our first official Twitter Spaces, so very exciting. Okay, let's go ahead and get started. Yeah, so first of all, welcome everyone. This is the Twitter Spaces to talk about Lagrange, our ZK coprocessor, and our roadmap towards mainnet. But we'll be addressing different questions from the community as well near the end. To start off, I'm Sherry. I lead marketing at Lagrange Labs. And Ismail, if you want to do a quick intro as well.
Yeah, so my name is Ismail. I'm the founder of Lagrange. Hopefully you guys have seen some of our tweets or have been on our Discord. But for those of you who haven't, we build decentralized proving, ZK coprocessing, and a bunch of very innovative technology in the ZK space. And so, yeah, I'm very excited to be here and to see some of you for the first time and see some familiar faces in the audience as well.
Yes, definitely. Okay, so to kick it off, I just wanted to kind of give an overview of where Lagrange is in our journey under this theme of the Lagrange expedition, right? In the last few months, we've been in Euclid testnet. We've launched 2 protocols, the state committees and our ZK prover network on EigenLayer as ABSs, and we are working really hard to launch what we're calling ZK Coprocessor 1.0, and on this very rapid and exciting journey towards launching mainnet for our ZK Coprocessor. And so, yeah, maybe on that thought, this Lagrange expedition is basically kind of a way for community members to join in and help us build towards this exciting mainnet launch. There are different ways to participate depending on your interests and experience. There are community quests that we are releasing on a weekly basis throughout August and September and onwards for different tasks you can do on Galaxy to just help us test, give us feedback, learn about Lagrange's protocols. And another way you can participate is also by running provers, right? We have launched our ZK prover network, currently has more than 60 operators, I believe, including really, top teams like Coinbase, OKX, P2P, et cetera. And so if you are interested in becoming an operator for our prover network, you can actually do that as well. And you can sign up on our website. And then lastly, obviously, building with Lagrange, the ZK coprocessor, our state committees. We're talking with a lot of cool partners right now who are integrating our tech to unlock different use cases. If you have an idea or some pain points that can be addressed by our ZK coprocessor, there is also a way to kind of reach out to us and we can help onboard you with our products as well. So with that said, maybe to kick off, Ismail, I was hoping if you could talk a little bit about, what's the overarching mission at Lagrange and how specifically our roadmap plays into that mission.
So Lagrange was founded almost 2 years ago at this point with a very simple mission. How can we enable blockchain data to efficiently be used
Ismail, I think you're
on-chain?
still muted if you're saying anything.
Oh, you can't hear me? Can you hear me? Can you guys hear me? Hello? Can you guys hear me?
We're still not hearing you if you're trying to say anything.
You can't hear me. Okay, you're good. So it sounds like
maybe some technical difficulties. Let's give them a few
folks
seconds.
back channeling. It sounds like they hear me. So either the issue's on my audio or it's on Sherry's audio. So let's just figure that out real quick, and then we'll get back into the meat of this. But okay, it looks like folks can hear me. Kashish from the audience and some other folks can hear us. All right, so let me just dive into that to Sherry's question about Lagrange. So Lagrange was started 2 years ago with a very simple vision, which is how do we scale what we can do with blockchain data on chain and between chains. For about 10 years, we've been asking the same question in blockchains, right? Every L1, every rollup asks the same question, which is how do we enable developers to write more expressive, larger, more data-intensive applications on the chains that they're already on? And everyone has, for the last decade, answered that question the same way, which is come leave your chain, come to my chain and build your application on my rollup, on my L1. Leave Ethereum and come build over here. This is the story that Aptos sold, the story that Sui sold. It's the story that all the L2s on Ethereum sell. And what Lagrange believed foundationally that there was another way. Developers could stay on the chains that they're on and could access more computation where they already are using zero knowledge proofs. They could sit on Ethereum and they could request zero knowledge proofs of computation and verify those proofs back on Ethereum. They could sit on Optimism and request zero knowledge proofs of computation and verify those proofs back on Optimism. In essence, they could scale their applications where they already are. And so in the journey of Lagrange, we started with this very simple vision. We've been growing fast since. We've been working with a lot of the top projects in space. Hopefully some of the people here have seen some of our work with EigenLayer, with Mantle, with Coinbase, with OKX, with Kraken, with many of the top players in the space. And what we're excited about now is this inflection point where we are opening up, hopefully, the Lagrange journey to include everyone here, to be part of what we're building and to be part of changing the future of crypto. And so this is part of the reason why we're very excited for everyone to be here today. And so let me now give a little bit of a deeper dive into what is next. And so Sherry, I think, can ask the next questions.
Awesome. Yeah, sorry, some technical difficulties here. Yeah, and in terms of what the key use cases that you maybe envision Lagrange's ZK coprocessor impacting or solving, can you talk more about that?
Yeah. So foundationally, what we let you do is to take your favorite existing DeFi application or NFT application or the chain you're on and do more with it. So how can the NFT applications on Ethereum let users do new things? For example, how can I build loyalty programs on chain? How can I reward my most loyal users with incentives? Or DeFi protocols. How can I build yield-bearing assets, the things we all come to DeFi to use, the things that we love? How do I offer discounts and loyalty programs and DEXs? The beauty of Lagrange's coprocessor is it's a 0 to 1 for a lot of DeFi applications in terms of what they can offer their users. So we have a big launch coming very soon in our journey in the next couple of weeks that will really show some of the best use cases that many of our users will be able to do. Top teams in the NFT and DeFi space. And to put it concretely, we recently announced a partnership with EtherFi as well as Renzo, two of the top LRT protocols in DeFi right now. And both of them are very excited to use Lagrange's ZK coprocessor for incentives and rewards programs. So as you use these DeFi protocols, you get additional yield and additional benefits that are powered on the back end by Lagrange's scalable zero knowledge proofs. We see a future where the whole industry runs on top of zero knowledge proofs generated by Lagrange. And so I can also talk a little bit about.
Yeah, and we recently launched the ZK Prover network on EigenLayer. It made a big splash, right, within EigenLayer and respective communities. Yeah, and so what would you say is next for the ZK Prover network?
So at its foundation, you can think of a prover network like the next generation of L1s. It is a base layer to offer something to the vast majority of the crypto market. L1s sold block space. Prover networks sell proofs. And so Lagrange's prover network is the first production grade, production ready prover network in crypto, currently being operated by many top operators like Coinbase, OKX, Kraken, and delivering proofs across both our state committee and our ZK coprocessor products. These proofs are integrated into protocols like Layer 0, Axeler, Polymer, many of the top LRTs, Mantle, etc. And so what we're excited about next is how we can expand the prover network, both with high quality operators from institutional grade operating groups, as well as operators at home, like hopefully many of you here, and how we can expand the types of proofs we serve to applications that are delivering differentiated zero knowledge compute. And this ranges from rollups to zkML to zk-TLS protocols. At their core, we anticipate a future where the entirety of the ZK space rests on top of prover networks like Lagrange.
Yeah, definitely. And so on the topic of, operators joining the network, I think we actually had a question from the community submitted earlier. Are we willing to accept even smaller operators into the Lagrange network?
Yes, we are. The way I think of Lagrange and what we're building in Lagrange is hopefully a community different than anywhere else in crypto. There's this trend I have seen over the last 6 months where a lot of communities are migratory. They follow a company until that company releases a token. That company releases a token, then they leave and go somewhere else. If we think back to the best communities in our space, the communities from the last cycle, the communities that still exist today, Ethereum, Solana, and some of the ones that don't, like Cardano to some extent, Polkadot to some extent. What they had were people who stuck with those communities as they scaled and were richly rewarded for doing so, who became fixtures and components in an ecosystem that they were members of. They were not just passerbys through. And so everything Lagrange does is going to be and will continue to be community centric. And because of that, we are very excited to welcome anybody who wants to run a prover, not just institutional operators, but anyone at home. One moment, folks. I think we're going to bring Travis
Awesome.
up.
Yeah, okay. I think right now maybe we can go into other questions from the community. Let's see here. Okay, yeah, beyond the technical capabilities of the ZK coprocessor, I think we talked a little bit about compelling use cases or applications earlier, but how do you plan to expand the Lagrange ecosystem to attract developers and users from outside maybe the traditional blockchain space?
Yeah. So I think it's important to think of zero knowledge proofs as a new component of the technology landscape. I think the applications of zero knowledge proofs are not solely isolated into crypto. The ability to have verifiable compute over data, one of the things that Lagrange offers, is a foundational primitive in uh, in a bunch of applications in Web2. I started my career actually working for a financial services company, Manulife's John Hancock, and it's a multinational insurance company based in the U.S. and Canada. And one of the major issues they faced was how can we effectively share data with other major web or TradFi players? If I wanted to determine the overlap of my customers and your customers, and we're two different TradFi companies, how do I do that without showing you my whole customer list, without showing you all the social security numbers? It just doesn't work. And so at the core, a network to trustlessly generate zero knowledge proofs has vast applications within both Web3, Web2, and in TradFi. And so when we talk about the future of Lagrange, you're talking about a network that has the capacity to deliver value, not just in an isolated portion of the technology ecosystem, but across all major companies leveraging technology. And so, yeah, we expect to be able to pull in a bunch of community across both Web3, Web2, and TradFi.
Cool. We have here maybe some more technical questions. Just a note, we plan to be hosting technical office hours on our Discord soon. So please feel free to attend those as we announce them. And those are a great place to talk to our engineering team and ask any specific technical questions or inquiries. But here's one. Can you please provide more technical details about the storage database than what's shown in our docs? For example, which ZK-friendly hashing is applied, what's the subset of storage slots selected, what types of ZK queries it currently supports, and so on.
Yeah, that's a great question. And so thank you guys for asking technical questions, because this is our favorite thing to talk about. So at the core, you can think about our coprocessor as using two primary components. The first is a pre-processing of data, and the second is a verifiable query over the data. And so the way the pre-processing works is we prove that the storage of a smart contract within a given block and then over a range of blocks is equivalent to a ZK optimized structure that's efficient to compute proofs over. So put simply, if I was to compute a bunch of inclusion proofs in computation over the Ethereum state, way too expensive. It would be massive proving time, it'd be very expensive, nobody would want to use it. This is why a bunch of other projects in the space doing ZK co-processing have never been able to gain users. It's just too expensive for these teams. And so what Lagrange realized a while back is one of the things we can do is take the data over a series of blocks and verifiably prove that that data is equivalent to a new data structure. In this case, instead of it being the Ethereum storage structure built with an MPT tree with obviously a linked list of blocks, it is simply a giant binary Poseidon 2 Merkle tree that is provably equivalent to the subset of storage you want to compute over on Ethereum. Once we have that equivalent structure, which is a Poseidon 2 binary Merkle tree, we're able to then structure very large computations over that don't have to deal with the ZK unfriendly or the finite field unfriendly structures of Ethereum. And so put simply, what this lets you do is to have very, very performant, very efficient ZK queries that any user can specify in SQL, so very easy to specify language, that run at scale cheaply for many of the major applications in the space. So this is a fundamental innovation from our research team led by Babis Papamanthru and Travan Srinivasan and Demetrius Papadopoulos, who have invented many of the core mechanisms that have let our team be able to leverage this type of compute.
Great. Yeah, I think I'm still having some technical, excuse me, technical issues. So I've brought on my colleague, Travis, who is a co-host now. Travis, did you want to take over the question and answer portion?
Yeah, sounds great. One sec. Awesome. So yeah, Ismail, we'd love to hear how the Lagrange protocol ensures the security and integrity of cross-chain state proofs, specifically when handling submissions from potentially untrusted users.
Yeah. So I think the beautiful nature of a zero knowledge proof is the security is derived not from the person who submits the proof, but from what the circuit proves and what the public input to that proof is. And so in the case of our ZK coprocessor, the public input to that proof, so the thing that you're proving computation over in this case, is the block header of a chain in question. So if you're in a single chain context, you're on Ethereum, and you're proving computation over Ethereum state with our ZK coprocessor, it's entirely based on the block header of Ethereum that you can access from within Ethereum. So there's no additional security assumptions over who submits the proof. The only security assumption is that Ethereum is honest and Ethereum is accurate, which is the foundational assumption you have to make if you're building on Ethereum. Now, as Travis mentioned, the cross-chain context. In the case of our state proofs, the beauty of the cross-chain context is that we have restaked security behind attestations to what the state of rollups are that we often sell as proofs to cross-chain protocols. So we work with Layer 0, we work with Axeler, we work with Polymer, and with all of these partners, the kind of core thing that we offer is a proof that there has been a sufficient amount of restaked voters who have signed the state of a blockchain or a rollup at a point in time. And so what the proof tells you in the end of the day is, hey, there's $7 billion of security that has been committed to ensure that this state is accurate. And so what that gives is a as secure of a representation of state as you can get in crypto today, right? $7 billion behind the state of a chain, of a rollup at a point in time, is about as secure as you can get. And that's how, in the context of state proofs, we can guarantee security.
Awesome. Thank you for that. The community has some more questions, specifically on the types of capabilities that Lagrange is going to build out. What kind of capability will there be to decentralize the technology in the future?
Yeah, so it's decentralized today, and that's the important thing to think about here. Lagrange launched day one decentralized because decentralization, we believe, is a foundational principle in building blockchain applications. So our prover network that generates the state proofs and the coprocessor proofs is already decentralized. This is why many of you can run provers at home. This is why Coinbase, Kraken, OKX are already running provers. So when you get a proof from Lagrange, you aren't getting a proof that Ismail computes himself. You're getting a proof that's computed by a decentralized group of provers. And so that's something that we're very excited to offer to the community, because we believe that it means that both the safety of the computation you get from Lagrange is based on our proofs, and the liveness of the computation, the liveness of the proof, so you getting the proof when you ask for the proof, is not guaranteed by us. It's guaranteed by a decentralized network of some of the best operators and provers in the space.
Awesome. Yeah, that's important to keep in mind. The technology is already decentralized. Some community members want to make sure that they understand the technology exactly as it works. So from one person, they would like to understand correctly that the goal of the project is to connect all blockchains into one, and if not, what is the goal? Please tell us more about specific examples and use cases, for example, in the DeFi sphere.
Yeah, that's a great question. So I wouldn't say the goal is to connect all blockchains into one. I think that would be the goal of maybe a messaging protocol or a bridge or an aggregation protocol. What our goal is to generate the zero knowledge proofs that will power the next generation of applications in crypto. And in the case of our coprocessor, that's generating proofs for data heavy on-chain applications that need to have robust computations over historical transaction storage and receipt state. For the state proofs, that is generating proofs of the state of rollups, and then for other applications, that'll be us generating other types of proofs as well. But at our core, what we build is a foundational infrastructure to power the future of zero knowledge proofs on blockchains. And so some great applications of this are messaging protocols and bridges that use our state proofs, the aforementioned Layer Zeros, Axlers, Polymers, and many other great teams, or DeFi protocols that want to build rewards or incentive programs on top of our proofs. Think EtherFi or Renzo, or even NFT protocols, some tier one world-class NFT protocols that we'll announce very soon who are working with us, who want to build rich and enjoyable on-chain experiences for their users, all of which are powered by zero-knowledge proofs generated by Lagrange.
Awesome, thank you for that explanation. And another question regarding the technology. So the main technology supporting off-chain data processing is ZK MapReduce. Is that correct or not correct in terms of Lagrange's ZK coprocessor? And can you tell us a bit more about the research and protocols and if there are other things in the pipeline in development?
Yeah, so we like to call it ZK MapReduce. That's an older name of what we called our underlying proving system. Right now, it can be much more simply thought of as ZK SQL or verifiable SQL. Simply put, you can write an SQL query, the same thing you would write over a database, and you can prove that computation over blockchain data and verify that computation back on chain. That is foundationally the best way to think of it. And to talk about the research behind it, so Lagrange has arguably one of the strongest research teams in the zero knowledge space right now. So our chief scientist, Babis Papamonthu, is one of the chairs of the cryptography lab at Yale. Demetrius Papadopoulos is a professor on our team at HKUST. Shravan was a former PhD student of Babis. And we have a number of other PhD students on our team right now focusing on core cryptography, mechanism design, and distributed systems research. And so the first paper that many people might be familiar with that Lagrange published is something called RECL trees, which is a new authenticated data structure that has properties of updatability for MapReduce computation, which is one of the things that's currently powering our coprocessor. We have other papers, one called Perseus that we've talked a little bit about previously, that are coming out very soon, as well as some interesting work on mechanism design for prover networks and some other interesting design on recursive snarks that we really think are going to be this massive unlock for the speed, the performance, and developer experience of building on our products. And at our core, you can expect Lagrange to continue to publish top-tier research, thanks to the team that we've assembled.
Awesome. Great. We have one more bit of a technical question. One user would like to know what your point of view on the issue of counteracting toxic data that has the capacity to do DDoS is, attacking verification nodes through complex operations.
So to make sure I understand the question correctly, I think it is what stops you from blocking a prover by requesting some computation that's too large for the prover to do, that DDoS is the prover. Keep in mind that to request a proof, you have to pay a fee to the prover. And in doing so, the fee that you pay is proportionate to the amount of constraints in the circuit. Therein, if you want the prover to prove something that's too large or with too much data or is too intensive, the amount you would have to pay is proportionate to the size of that proof. So if your proof takes 50 hours to compute, you're going to have to pay a lot of money. Fortunately, the things that every user, or mostly every user, wants to do don't take 50 hours, they take a few seconds. But if you try to DDoS the network, you would have to just pay an inordinate amount of money and you would quickly bankrupt yourself. Moreover, some of the interesting mechanism design we have, which we'll be releasing soon, means that the network can dynamically price itself based on a bunch of heuristics over proof request volume, which makes it so that the resource pricing of the network will continue to scale as someone DDoSes it, quickly bankrupting that person. The example I would give you would be something like Ethereum, right? You could structurally not DDoS Ethereum, as the more blocks you try to fill, the higher the base fee goes, and then obviously eventually you'll run out of money.
That makes sense. Thank you for that explanation. Well, yeah, that was the bulk of our community's questions in regards to technical information. We have some community-specific questions that I think we can answer on this space. So I'll just go through these, and if anyone has any more questions, feel free to add them below the space itself. So some people have joined the Lagrange expedition, which is a campaign that launched around our build up to mainnet. Some people are interested in understanding how beginners who are not technically inclined can join testnet in the hopes that all or most of the tasks will be fine to try without much developer knowledge. And for that, yes, we will definitely have a variety of quests, and we already do have a variety of quests on the Lagrange expedition in Galaxy. So you can check that out, and a lot of the quests are to test your knowledge on Lagrange, to explore the ecosystem. So we've made sure it's very friendly for our non-technically inclined friends, and we are adding new quests regularly, so stay tuned on Twitter and Discord to hear the latest updates. And another community question we have was wondering if the previous Galaxy quests before the expedition launch will count as contribution for rewards and for community recognition. So we've gotten a few questions around this because we know that we included some Galaxy quests prior to the Lagrange expedition. And to clarify, any and all contributions to the community, whether it was during Euclid testnet or the Lagrange expedition now, will be part of the consideration for community recognition. So we appreciate, and we'll definitely make sure that our community's efforts are seen. Yeah, and I think that is kind of the bulk of the community's questions for the expedition. Ismail, if you have anything else to add in regards to what we're excited about developing and the path ahead.
Yeah. So one of the things I wanted to add for everyone here, which I think is a very important point to recognize, is despite Lagrange being a highly technical product, you don't have to be technical yourself to be part of the community. We want anyone who finds the vision of building a future of crypto based on verifiable, trustless compute interesting to be part of our community, irrespective of if they're technical or non-technical. In terms of the roadmap of Lagrange, much of the products that we build are highly technical. Much of the research that we put out is acclaimed both in the engineering context of the space as well as in the academic context of conferences and publication venues. And so Lagrange is very confident in those points, but the community that we build, we want to encompass everyone, regardless of how technical they are. And then in terms of the future of Lagrange, I would recommend everybody stay tuned for some very big announcements we have coming very, very soon. On the commercialization standpoint, our company has just been taking massive strides in partnering with some of the largest teams in the space. Many of those have yet to be announced and will be coming to fruition very, very soon. So we look forward to announcing and having many of you hopefully celebrate alongside us as Lagrange continues to scale.
Wonderful. Thank you so much. Yeah, we're all very excited about the future ahead. Thank you, everyone, for joining, and feel free to add any other questions that you have below this space, and we will do our best to answer them in a reply. Hope everyone has a wonderful day.
Thank you, everyone. Thank you for coming.
Yeah, thanks so much. So I think that wraps up our first Twitter Spaces. Thanks for joining and bearing with us as we had some technical difficulties. But yeah, lots of great questions. If you have anything else that you're wanting to ask, we'll be doing more of these in the future, but always on our Discord, feel free to reach out to us and let us know what you're thinking about, what you'd like to see more of. And we look forward to hearing from you and building towards the mainnet launch of Lagrange's ZK coprocessor together. Thanks so much, and we'll keep talking. Take care, everyone.